Hi there, this is Jacob Nash, Algebra Lessons. This is Unit 1, Lesson 2, on functions. Okay, so I'm pulling up some notes here that I'm going to go over because I don't want to forget anything. Because like I said, I'm not a completely certified teacher. I just know about the subject and I can teach it. But I want to make sure that I have everything right that's at the up-to-date curriculum for you. So, alright. So there's this might be a kind of long video. So we need to remember what functions are because we learned this in Algebra 1. Once again, these are videos about Algebra 2, but this still is helpful for Algebra 1 because I'll explain it as if you've never heard it before. Well, first, let's look at a relation. So what's a relation? This is just a set of ordered pairs. And we can have, what is an ordered pair? I mean, hopefully you know that, but in case you didn't, it's the things that are like this, in parentheses, and they have a comma, and then the first one's an x value, and the second one's a y value. You've been doing that since elementary school, probably. At least middle school. Well, you might be in middle school if you're taking Algebra 1 and watching this video anyways. But, so a relation is just a set of those ordered pairs, and that can be within these brackets. So there's brackets, braces, I meant. These are brackets, and these are parentheses. But within the brackets, there's ordered pairs. So whatever those numbers might be. I'll just say x, y, because this is just an example. So x, y, x, y. Alright? That's what a relation is. Now, there's domain and range, and then you might be like, oh great, I remember that. And it might sound foreign to you, but you also might remember it. And domain just means the x values. It's the x values. So domain is x values. And range is the y values. So that's not that bad. I mean, what in the world? You just have to look at which one's first. Domain, second one, range. So, just to give an example, let's give an example. Alright, 0, 1, 2, 3. Just a simple example. Here's domain. Sorry, I didn't mean to write that. And that's the domain. Range, 1 and 3. So we could say that the domain is 1, 0, 2. And then we have the range that's 1, 3. There you go. Now let's review the ways that we can show data in algebra. What can we do? There's 4 basic things we can do to show these ordered pairs. Well, or these sets of values, like in the relations. So you can do ordered pairs. So number 1 is ordered pairs. Once again, if you didn't see the last video, sorry about the background music. So that would just be x, y, something like that. Oof. Second thing that we can do is we can do a tabular form of data, which just means table. Tabular, it sounds like table. And so that's like something like this. We have x on this side, y on this side, and then we write whatever it is. Then we also can do mapping. That's when you have these ovals, 2 ovals, and then you have numbers, so like 403, and then 5, 1, 2, and then you do something like this. That's what that is. And then you also can graph it, obviously. And you know what that is, that you just have something here, wherever your points are. There you go. So, Now, let's see. What's next that we'll go over? Let's see. There's different types of graphs. There is discrete and continuous. Discrete is when there's just random dots and they're not connected, like that. And continuous is when there's actually a line or a curve or something like that. So that's what that means. That's simple. So then we have something that you're probably going to remember, and it's not that hard, but let's first talk about a certain symbol that we're going to use. What is that thing? It looks like maybe some eyes, but that's not what it is. I mean, or a sideways 8, but that's just infinity. I mean, you probably know that, but in case you didn't, that's infinity. That's what that means. What is infinity? It just means it goes on and on. Numbers don't ever stop. They just keep going. And the lowest number is negative infinity, and the highest number is positive infinity, or you just have nothing there. So we're going to use that. And we need to state the domain and range of graphs. That's something you need to do. And you did this in Algebra 1. But if you are watching this and you are in Algebra 1, then maybe you didn't do this yet. But this is something you do. So here's a graph. I'm not going to draw all of the lines because that would take forever. But let's see. So you can have certain things on graphs. You can have a line that has dots on the end of it. The dots can be colored in or not. And then you have arrows. So when there's dots that can be colored in or not, that means that it stops at that point. Wherever that dot is located, that's where that range of values ends. That's one endpoint of it. And if it's colored in, then that means that it includes the spot where it is. And if it's not colored in, then it doesn't. I'll just have to say include. And then if it has arrows, that means it goes on forever, meaning that it would go to negative infinity or positive infinity. Either of those. So that's how we can find our values. So let me just draw one and let's see an example. We have a dot here. And then we got another dot here. So what is this? Well, let's just say where these points are. So we can say that this point is at 3, negative 3. And that this one is at negative 2, 4. So what's the domain and range? The domain. Well, here's how you answer. You need to have two numbers. They could be infinity, but it needs to either be in brackets or parentheses. How do you know which one? Well, if it's a colored in dot, you use brackets. If it's a not colored in dot or arrow, you use parentheses, because that would mean infinity or not including. So that's how you know. So let's see. Domain is the x values. So let's go in blue the x values. We have 3 here and a 2 here. And you always go from left to right, so we'll do the one that's to the left the most first. That's negative 2. But that's a not colored in dot, so we need to do parenthesis. Negative 2. And then the next thing we have is a 3. But the next, we need to have a bracket here because this is a colored in dot. That means that's all the values, all of the x values in this data set. Then let's look at the range. Let's color this in red. We go from hang on a second. Sorry about that. So we go from down to up for this one. So we do the down one the most, and that's -3, and it's colored in, so we do bracket. And then we have 4 here, not colored in, so we do that. So there you go. That's what we do for this one. Let's look at an example where we might have an arrow. That means something different. We have to do something different for that. Okay? Alright. Now we have our axis right here. And let's say we have this. What would this mean? Let's say that this spot is at -2, 0. And this, we can't obviously say what that is, because that just goes on and on, so we'll just write infinity right there. What's the domain? So the x values, we go from left to right, so this way, and remember we go up for the y values. So here's what we see. We see -2. So let's just put -2, and that's colored dot, so we do bracket. And then we go all the way into infinity, because of that's there, and whenever we have infinity, we do parenthesis instead. And for range, we go from bottom to top. We have a 0 here. And then we have to say infinity also because it's up. And why isn't it negative infinity? So just to review, there's positive and negative directions on graphs, and here are the positive ones. If something goes to the right, or if it goes up, it's positive. And this is going right and up, so that's why it's positive for both. But if it's going left or down, it's negative. So if this thing was pointed like this, we would have still a positive y because it's going up, but we'd have a negative x because it's going down. So there you go. That is how we can graph our and find our domain and range from a graph. Now, what is a function? Let's finally look at functions. So these functions are relations, and this is in which the domain is paired with only one range. So each domain only has one range. This is very important because this shows if it's a function or not. Here's what I mean. Let's say we have 2 x values. These x values can only point to one y value. If they have 2, then it's not. We'll explain this more later. So you see? That's what it is. Let's now look at examples of what would and would not be a function. So let's first look at mapping. So that's where we have the ovals. So let's say that our x values are 2, 4, and 7. And our y values are 0 and 1. Let's say this is what happens. Okay, so we have a 2 going to a 0. So we have a 2 to a 0. Then we have a 4 going to a 0 and a 1. And then we have a 7 only going to a 1. This would not be a function. Not. Why? Because the 4 points to 0 and 1, and it can only point to one thing. So no, that wouldn't be. If it only pointed to 1, then it would be. But let's look at a different example. So let's say we have 1, 2, 3, and 4, and then we have 5, 6, 7. I don't know. It's simple. Let's say we have the 1 points to the 5, the 2 points to the 6, the 3 points to the 6, and the 4 points to the 7. This is a function because two x's can point to the same y, but one x cannot point to two y's. So, yes, no. There you go. Now, we can look at a table. Same thing applies. So, for a table, let's say we have -2, 3, 4, -2, 0, 4, -1, 9. If you see two of the same x, then you already know it's not a function, unless the y's happen to be the same. So there, you see that one x still points to two different y's, so no, not a function. What if I changed this 9 to a 0? That makes it a function because this is just a duplicate thing, so that's okay that there's two. What if I had this as a 4? Or, wait, no, sorry, not 4, that's a bad example. 5. And would that be 1? Yes, because it's okay for there to be the same y that goes to different x's. So that's a table example. Now, what about on a graph? There's something called the vertical line test, VLT. This means that you can put a pencil on a graph vertically. So vertically is this way. And if 2 points touch at the same time on that vertical line, not a function. So, let's look at some examples. Let's just have some random points here. And they don't exactly have any ordered pair that I'm attaching to it. We can also have lines. It doesn't matter if it's discrete or continuous. Okay, so we have, this is discrete, this is continuous, and this is continuous. But that doesn't have anything to do with whether it's a function or not. So, let's do a vertical line test. Let's see, does this thing work? Maybe we can use this ruler. Okay, this thing does work. Well, I didn't actually draw this right. So let's see. Do any points touch together there? No. 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 Nah. Yes. That means that's a failure right away. So that one is not a function. That means that these would have the same x value. That makes sense. They have the same x value, but different y's. That's why. So let's just say this one would be 3, 5, and this one's 3, -3. You can't have the same x with two different y's. Alright, let's look at here. Oh, already. There's so many spots along here. Over and over and over that there's two parts. So a circle would never be one. And here, there's no spot where two touch, so we have another, oops, don't know why this thing scrolled. For this one. Don't know what's wrong with this. Yes, for this one. So hopefully you can see how that applies. But now we need to actually do some math. So let's put this ruler thing away. And let's see. So sometimes you need to find functions. And so the functions will have an fx. Hopefully you remember this. Why did something red just randomly show up right there? Okay, so fx. You say this as f of x. So what does the f mean? F means function. X is what's going into the function. So in a function, something goes in, something comes out. And what goes in is the x, and domain, and what goes out is the range or y value. Fx pretty much is the same thing as y. So if you're looking for fx, then you're really looking for y. So let's say that you can use any variable in here. Anything can go into there. It can be any letter A through Z. But actually, there's other things that can go in there too, because any really symbol could work. So you might have some Greek letters that go in there. You could have theta. You could have pi. You could have delta. You could even have international letters, like a AE ligature. Oh, that's not a very good thing. OE ligature, or A with the dot on top, or anything like that. But that's rare. Usually you only see that. Same thing applies for this F. It doesn't have to be F. It could be G. But it's depending on what you're measuring. Like, let's say you're measuring speed or velocity. You might use V. V of C or something like that. You could do that. But it's whatever the word problem says. So let's say that fx equals 3x plus 1. What is f of 3? What does that mean? We just replaced x with 3 here, so that means do it here too. That's all you need to do. So we substitute in 3, we get 6 plus 1, and then that's 7. So f of 3 equals 7, which means if x is if x is 3, then f of x is 7, or just y is 7. So that's what that means. That's simple. So you can do any problem like that. But there also might be something like this. Let's say, let's not do f of x this time. Let's do something else. Let's say h of a, as in A, equals 17. What is A? Well, we actually would need to know a little bit more information than just that, because we need to also know we need to know what HA also equals in terms of A. So we also need to say that HA equals 3A squared plus 4. That means that we just need to, if we find out that that equals 17, then we just need to say 17 equals 3a squared plus 4. We can solve this way. We do minus 4 on both sides, and then we get that 3a squared equals 13. We can divide by 3, and when we do 13 divided by 3, we get 4.3 approximately. So a squared is 4.3. Then we take the square root. So the square root of 4.3 is 2.1 approximately. So that means that what's wrong with this thing? A equals 2.1. There we go. That's how you do it. Don't get confused that I'm using an international letter. It doesn't matter. You could have O, you could have B, you could have X, anything like that. So, well, that would actually be it for this video. Thanks for watching, and stay tuned for more videos. Thanks for watching.